All right, so we are continuing on with trigonometry, and in this set of notes, what we're going to do is we're going to talk about the Pythagorean identities. Now, the points here say that there's only one, but we're actually going to be learning about three of them in today's class. So, the first thing is how to get the Pythagorean identity, and what we're going to do is we're going to start with what's called the unit circle. And what's special about the unit circle, it has a radius of 1 unit all around, as you can see from the coordinates here. So what we're going to do then is we're going to draw in a right triangle. And the unit circle is used a lot in IM3, but we are just focusing on the first quadrant. We're going to call theta that angle right there. So over here on the right side then is a bigger triangle, just so it's a little easier to see. Because we're in the unit circle and the hypotenuse is the same as the radius, we know then that the hypotenuse is 1. Now what we're going to do is we're going to find the other two sides for our triangle. Since we've already labeled where theta is, we know then that this is the opposite side, here's the adjacent, and then here's the hypotenuse. And then we can use SOHCAHTOA in order to find the other parts of our triangle. So the first one is we know that sine of theta is equal to the opposite over the hypotenuse. We already know the hypotenuse is 1, so we're going to put that in. Well, over on the right side, it's just opposite divided by 1, which is just the opposite. So that tells us then that sine of theta is our opposite side. Then we're going to find the other one. And in this case, we know, again from SOHCAHTOA, cosine equals the adjacent over the hypotenuse, which is again 1. Over on the right side, that can simplify. So then now we have cosine of theta is equal to the adjacent side. And now that we have labeled the side lengths, cosine of theta and sine of theta, we can then go ahead and create our equation from that, which, as the name implies, Pythagorean identity, we're going to use the Pythagorean theorem now. So that means that we will have sine squared, or maybe I should write it this way, sine of theta squared plus cosine of theta squared is equal to 1 squared. And if we simplify that, that gets us the equation down there. This is how the questions will typically appear then when you're asked to use one of the Pythagorean identities, at least for now, I should say. What we'll do is we will be given one angle, and I don't know if I mentioned this before. It's always going to say it's an acute angle, and the reason for that is it's just going back to the unit circle. Acute means that it's going to have to be in the first quadrant. If it wasn't acute, it could end up in any of the other three, and then that would be where some of our values could be negative, but we're not going to be dealing with negative values for IM2. We'll just have to worry about the positive values. So we already know that sine of W is 7 over 25. That was given. So of course, cosecant of W is the reciprocal, 25 over 7. Now what we're going to do is we're going to use the Pythagorean identity with this value in order to solve for cosine. So that is the equation that we have. I'm going to make this substitution then. And then all we're doing is we're just going to solve for cosine. So we're going to get 49 over 625. Yeah, I'm kind of running out of space, so I'm going to move this over. Then I'm going to subtract that fraction from both sides. So that's going to give us cosine squared equals, when we subtract, it is going to be 576, I believe. And then the last step is we just have to do the square root of both sides. And so this part is why it was important for us to know it was an acute angle. As I told you, we're only going to deal with the positive values for this class. When you get to IM3, that's when you have to start considering, is it negative or is it positive, or am I supposed to include both? But in this case, then the square root of 576 is 24. And we know that the square root of 625 is 25 because back at the beginning, 25 squared was 625. So that's it. That is another one of our values. So cosine of 24 over 25, which means secant is 25 over 24. All right, does anybody want to give a shot then to what tangent is?
Seven over 24.
Exactly, good. 7 over 24. And so, everybody, there's two ways you could solve that. You could either draw a triangle and just know that your sides are 7, 24, 25, and then you could use SOHCAHTOA, or another way is sine over cosine, and then the 25s would have canceled. So either of those are how you could find that was 7 over 24. Okay, and then now we know that cotangent is 24 over 7. Okay, are there any questions with this?
No.
No? Okay, so what we can do then is we'll move on to the next one. So I'm going to rely on all of you a little bit more for this time. So we're told that A is an acute angle and cosine of A is 3/4, and we're supposed to find the other 5 trig ratios. So can somebody tell me how to set up the equation?
Cosine. So sine squared A plus 3/4 squared equals 1.
Good. Yep, and then now we just need to start simplifying. So we get 9/16. We're going to subtract that over, and that's going to give us 7/16. And then we're going to do the square root of both sides. That color. There we go. This one doesn't work out as nicely. Sine of A will be equal to root 7 over 4. Okay. Can somebody then tell me what will cosecant be equal to?
Root 7 over 7. Oh, wait, no.
You're close. You're just missing one thing.
4 root 7 over 7.
There we go. Yep. Good. And then everybody just, I'll put this off to the side because it was originally 4 over root 7, but then we have to multiply by the reciprocal. So that's how we get 4 root 7 over 7. Okay. Secant will be a little easier. What is that?
4 over 3.
Good. Okay, and then can somebody give me tangent?
Square root of 7 over 3.
Good, and then cotangent?
Three root 7 over 7.
Good, and so this last one is just like what we did for cosecant. It was originally 3 over root 7, and then we had to rationalize. All right. Any questions on how I got this?
I'm good.
Okay. I still hear some furious writing in the background, so I think I'll wait just a little bit.
That's probably me.
Oh. Everyone, is it okay if I move on?
I'm good.
Okay. So, what I want you to do then is I want you to try this on your own. So B is an acute angle, sine of B is 5 over 13, and go ahead and find the other 5 trig ratios. There should not be any weird radicals in your answers. So if you want me to check your work without bothering or giving away the answers to anybody else, you could just type it in the chat and I'll respond there. Okay, I'll give you all about 1 more minute. All right, so we already knew what sine was, so I'm going to write that in. So can somebody give me one of the other 5?
13 over 5.
For which one?
CSC.
Okay, do you remember what CSC is called?
No.
Somebody else, what does CSC stand for?
Cosecant?
Nobody? Thank you, there we go, yeah. So this one is cosecant. Okay.
I don't know how I knew that.
Okay, so give me another one then. I'm a little surprised Adam hasn't spoken up yet. He must be AFK right now.
I'm right here.
Oh,
I was in the bathroom.
Is cosine 13 over 12 or 12 over 13?
there you go. 12 over 13. Yep. And then what else?
$13 over 12.
For which one?
Secant.
Yeah, 13 over 12. And then just as a reminder, everybody, secant is SEC. Okay, so then now we just have to do tangent and cotangent.
Five over 12.
Yep, 5 over 12 for tangent. And we know the reciprocal 12 over 5 for cotangent.
Briz.
What's up?
So the easiest way to find the cosine, is that through the Pythagorean theorem or whatever?
That is one way. One thing I was going to mention as well, though, some of you may have noticed this, and I remember when I taught Samantha Blake, she was the one who noticed this as well. Honestly, these questions that we're doing can be solved by just drawing the triangle as well. And you could do the Pythagorean theorem with the numbers rather than using sine squared and cosine squared. Because if we know that sine of b is 5 over 13, and that's the opposite over the hypotenuse, then the bottom has to be 12, and now you're able to solve for all of these anyway. So that's another way that we could solve all of these. However, there's going to be, I think I mentioned this last week, there's going to be a day this week where I want us to be doing other trig identities, and that's going to be something where I'm going to find some questions where we're required to do Pythagorean theorem, or Pythagorean identity, I mean, to solve them. But yeah, we could have easily just drawn the triangle and solved it with that too. All right, is it okay if I move on?
Yeah.
Yeah, okay. So the next thing that we are going to get into are the other two Pythagorean identities. So what I'm going to show here is how we get both of them, and they both start from sine squared plus cosine squared equals 1. So beginning with that, I'm just going to rewrite the equation down here. But let's say that I don't want one of those trig ratios in my equation. So I could just look at this and say, you know what? I'm really not a fan of cosine squared. So I'm going to divide that out. Well, whenever we divide something in an equation, everything has to get divided by that. And if we divide all three of those by cosine squared, that gets us then to our first, or I should say second Pythagorean identity. Any guesses as to what sine squared over cosine squared is?
Tangent.
How many tangents?
2.
Yeah, there's 2, so it's squared. Cosine squared over cosine squared, what is that?
One.
1. And now the last part, what is 1 over cosine squared?
Secant.
How many secants?
2.
2. So there you go. There is the second Pythagorean identity. Tangent squared plus 1 equals secant squared. And then the other one again, I'm going to start by writing sine squared plus cosine squared equals 1. And this time I'm going to say, you know what? I don't want sine in there. So I'm going to divide everything by sine squared. So what do we get at the beginning there? So sine squared over sine squared, what is that?
One.
1. Now cosine squared over sine squared, what is that?
Isn't that just tangent?
Not tangent, because earlier we showed that sine over cosine was tangent.
Oh, yeah.
But you're close, so instead of tangent, what could it be?
Cotangent.
There we go, yeah. So that one is going to be cotangent squared. Okay, and then our last one, 1 over sine squared.
Cosecant?
Good, yep. So this last part then is cosecant squared. And that gets us to the last Pythagorean identity. 1 plus cotangent squared equals cosecant squared.
But are we going to be using these two as well? Or are these ones for identity?
These can be used for some of our questions. And
Okay.
so like my next example, the book actually had the book did have a question. I'm saving it for either tomorrow or Wednesday. I don't know yet, but where you were going to be using one of these, which is kind of odd because it seemed like they didn't formally teach these equations, but these are useful as well. By the way, everybody, in case you forget, really the big thing I expect is you need to remember the top one here. Sine squared plus cosine squared is 1. And then for the other two, memorizing them would be good, but remember that the one on the left was found because we divided by cosine squared. And then the one on the right we get by dividing by sine squared. So if you forget the other two formulas down at the bottom, you just need to start with sine squared plus cosine squared equals 1, and then just start dividing things, and that will get you to the other two formulas. Okay, are there any other questions with these here? No? Okay. So I think I've only got I've got just one last example for us then. Okay, so here we're saying that x is an acute angle and secant of x is 2, and we're going to find the other 5 trig ratios. And I forgot to include this. I'm going to bring this over. Hopefully that copied it. Everything I wanted. No.
Paste image.
There we go.
Yeah.
Yeah, there we go. And then I think I'm going to have to use white, though. I don't think I can. Yeah, I can't erase that, so I'll have to use white just to get rid of them. But, so, and it shouldn't be sine B, cosine B, whatever, but we'll pretend that it's the correct angle.
Just white out the A and put B.
Or the X, yeah. Yeah, that'd be faster.
X.
You're right, that'll be faster.
I'm smart.
SMRT. Just like Homer Simpson. Okay, so So looking at this then, if we're given secant, and I'm just going to say let's use the one of the new Pythagorean identities to solve this. So we know secant is 2. I'm going to fill that in. Of course, we know what cosine is. That's 1/2. But I'm going to say, rather than using sine squared plus cosine squared, let's use one of the new ones. So what is the formula that uses secant?
The second one.
Yeah, so can you read that off? Or, yeah, read off what that equation is.
Tangent squared plus 1 equals secant squared. Or equals secant squared, yeah.
Yep. So that's the equation that we're going to use. So then let's put in our numbers. So that means that we're going to get tangent squared plus 1 equals 2 squared. And of course, 2 squared is 4. So then that leaves us with tangent squared of theta equals, I guess I should have been using b this whole time. Equals 3. We need the square root of both sides. And we find that the tangent of b is going to be the square root of 3. Okay, and then we can get cotangent. So what would cotangent be for this?
Square root of 3 over 3.
Good, yep, square root 3 over 3. And then, of course, that's because it was the reciprocal of root 3, which is 1 over root 3. But yeah, I would prefer, it's not wrong if you do it that way, but I still would prefer just to see root 3 over 3 because that's what you're going to see more often in this class and in the future. Okay. Now, does anybody have an idea of how we could get sine?
Make an equation.
So, like, which equation?
The first one?
Sine.
Yeah, we could.
Sine over cosine is tangent, so.
Ooh. Okay, I'm gonna write down both. So we've got that suggestion, and then also now looking at these two. So either of these will work for us. I have a preference, but I want to hear from the rest of you. Which one would you rather use? Do you want to use sine squared plus cosine squared, or do you want me to use the tangent equation?
A tangent equation.
Anybody else have any recommendations, preferences, suggestions, thoughts, declarations? I'm running out of synonyms.
Oh, I know.
Okay.
Oh,
So-
I should use it.
I'm going to say that I agree with Adam. However, Celine, I think you were the one who mentioned sine squared plus cosine squared. You can definitely do that as well. I just think it's going to take a little bit longer if you try to solve it that way. And I can honestly show how to do it both ways, but I think the equation on the right is going to be a little faster. And I think when you see what I do. I think you'll agree with it too. Since we know tangent of b is square root of 3, I'll put that in. We don't know sine of b yet, but we do know that cosine of b is 1/2. And then we just need to multiply both sides by 1/2. And it looks like we're already done because we got square root of 3 over 2. So we already have sine of b. If we were to use the other one, the sine squared plus cosine squared, we can still get the same answer.
It would just take longer.
Yeah. Because we're going to get sine squared plus 1/4 equals 1. Sine squared equals 3/4. Then we got to do the square root of both sides. We still get the same answer, but yeah, it took a little bit more work in order to get it. Okay, and then finally, what is cosecant?
Two root 3 over 3.
Good, awesome. And that's it. Yeah, so I just wanted to show all of you what it would look like then if we were to use one of the other trig ratios. I'm sorry, one of the other Pythagorean identities, sorry, in order to solve the trig ratios. So are we all good on this? Can I move on?
Yeah.
Yeah. So that is it. That is everything for this class. So the assignment here, like usual, I did put together a full set, but then I am telling you that you can skip some of them. So, and this time I remember to put in the notes. So there you go. Just 4, 5, and 11 are the ones that I think are enough to know everything that we're doing. 8 and 9 are just extra stuff if you want. So that's everything for class. You are free to go enjoy your extra 10 minutes then before your next class, or go take a nap.
Bye.
Bye. Enjoy
Bye,
your
everybody.
birthday.
Thank you.
Yeah, thank you.
Thank you.
Happy birthday.
Yeah, thanks. Bye.